Hello, everyone. Welcome to another Bounty episode of the Day Zero podcast. I'm Spectre. With me is Z. In this episode, we have some DNS rebinding stuff in an RCE and Tailscale, an RCE in Spotify's Backstage, and some fuzzing research on web vulns. Before we get into topics, quick notice that in 2 weeks, December 12th and 13th, will be our last podcast episodes for this year, and we'll be returning on January 9th and 10th. So just wanted to give a quick heads up for that. And yeah, with that out of the way, we'll jump into our topics. So our first blog post is an RCE and Tailscale by Emily Trow, and it's a bunch of issues in Tailscale, which is a mesh VPN service. So Z, I'll let you take this one away.
Yeah, and this one has a several issues. The way the whole post is laid out, I may not follow it exactly here. That it'll make sense later why I'm not necessarily going to follow everything in order. But I will say this: it starts off using DNS rebinding, which fun attack we've actually talked about a little bit. I had this spot the vol not super long ago that was based around just having a DNS rebinding issue. Um, This kind of takes DNS rebinding back from, I think a lot of times we see it talked about these days. It's more of like an SSRF bypass. Um, what I'd really kind of call, or what I'd point for is the history of DNS rebinding is more of the same origin bypass, where you'd have an attacker website and they rebind to something else to access like internal APIs and stuff. Almost something that's been, I don't want to say it's been forgotten about because it hasn't. There have been attacks like that recently too, but I don't know. I feel like it hasn't gotten as much attention or it's been overlooked a little bit. So this takes us back to that, rebinding and um the first entry point they noticed being something you could rebind on is the local API, Tailscale's local API. So this is running on, whatever client machine runs this API, local API, and you could rebind on that. That's running on localhost. If you're thinking ahead, you might realize that for an attacker to do a DNS rebinding attack to hit the localhost, they would have to be on a private IP address, so inside of like the internal network, and then they could rebind to these privileged IPs. Otherwise, like from an attacker's website just on the internet, you can't rebind um to a private IP. So that is a limiting factor at this point, although they do have a follow up as a secondary entry point here. You can rebind onto Quad 100. Um, Actually, I guess I'll keep going in, I guess, the post order, but with this local API, so this is the privileged API running on localhost. You're able to do a couple things when you're able to hit it. So ignoring the practicality of an attacker actually reaching that, once you're able to rebind, you're able to make requests to it. You can do patch requests to one of the update endpoints. Patch local API v0 prefs. It does expose the private key, so you could use that to communicate with the other services behind Tailwind, um, and impersonate this victim basically. More importantly, though, is you can become the control plane, which is effectively the control server it's communicating with. You can basically patch, update the control plane, tell it, oh, actually, the control plane is this server the attacker controls. And from there, the attacker can enable something like a tail drop to share files and then share a file onto their machine and actually get RCE by telling it to open that file or execute that file. When it comes to getting RCE, it does need to launch a file that already exists on the machine. Well, sorry, it does need to launch a file specifically, so you're not really getting control of like arguments or anything. But the way they kind of do that is using this tail drop to either drop a file or it'll download from WebDAV server, so it can pull down the file that gets marked of the web, so it's going to have this wonderful little warning there. Are you sure you want to run this file from the internet? So not zero click. It takes that bit of user action to even get it to run. But if they use tail drop, this file sharing feature, they're able to just drop the file on there, and presuming they can figure out where it got dropped because it's into the user's home folder, you would be able to basically just tell it to open that binary. Um, since this one is a little bit more privileged, they went through a whole lot of work here in their posts about how they found this chain and worked this out and, getting it working and then realizing, oh, we can't do this because you can't rebind onto the privileged IP. So they started looking for another way to get access to the same thing. What they ended up doing there is they started off by targeting this Quad 100, which is this special IP that Tailscale kind of takes over. Um, I'm not a Quad 100, I believe, is like a public internet IP, so I'm assuming they have ownership of that and a bunch of these IPs. I didn't actually go and confirm that, but at the very least, they use them, and if they don't have ownership over them, then they are probably causing problems for somebody out there. But I'm just going to assume that the company itself kind of owns them, and then they rebind them for their purposes here. Anyway, Quad 100, effectively, you can rebind it because that is a public, wide internet IP address. You can do the rebinding attack to get access to that, but it doesn't have a ton, but it does give information like the local IP address for their specific Tailscale device. And what's important about that is you can then take that and determine where the peer API is running. And then you can do a second rebind attack, rebind again, and get access to the peer API. The peer API is, if you remember that file sharing I talked about before, that happens over this peer API, where you basically do a put with whatever file you want in there. Do a put, it loads it into a temporary storage. It alerts the GUI that a new files come in, and that GUI will fetch um, through a GET request on the local API to actually download that file and put it where it's supposed to be. Fun thing there is when it goes to fetch that file, it actually fetches it using a GET request that's served with the content type text HTML, which effectively ends up being a XSS place. You can basically just upload HTML and get XSS that'll run on the local API through this. So through the peer API, upload a file or rebind to get onto the peer API, upload a file that gets triggered, and you can then trigger a get sorry. When I should clarify a little bit, when it's downloading the file, it's not like displaying in a browser. You're not getting JavaScript execution at that point, but through a request to the local API, it is served with text HTML, so you can embed an iframe or something of the local API, and it'll be served up that way with HTML. So you get an access that way. They did find that they had or they had a little bit of a challenge when it came to actually accessing this file because as soon as the file gets moved out of temporary storage, it's no longer accessible through the local API. However, if they send multiple requests in, for whatever reason, the file never gets deleted. Usually, once it downloads the file, it would delete it. There's some race going on there. Some things fail. They don't go into a lot of details about exactly why this happens, but effectively, multiple requests come in. They race over their access. Some of the threads fail, and so it never actually gets deleted, creating creating a location for a stored cross-site scripting inside of the local API. At which point you can kind of return to what I talked about at the very start of the post, using the local API, changing or with access in the local API, you can then change the control URL or the control plane URL, point that to an attack controlled server, which then gives you the ability to do code execution. It's kind of a fun chain there, and the last one is useful and like an attacker could definitely pull that off. Needing to be inside the network was a bit of an ask. But they resolved it here. On a whole, I do feel like the order of this post does come off a little bit weird just because they walk through all these things work and it's like, oh, it doesn't work for this really fundamental reason that should have been brought up earlier, I think. But at the same time, it's their story. It's how they it's most likely exactly what they did. Um,
Yeah, I do want to mention. the rebinding to private IP things, that did end up working on Firefox, actually. They have a little table here. So they didn't have to go the Quad 100 route for Windows and Firefox, but they did for like Windows and Chrome if they didn't have any special access. And that's another thing that's worth pointing out here, too. This attack chain would only work on Windows. Because basically, like Windows would host a server on a loopback IP, so that's kind of where you were able to get access pretty easily. But on Linux, they use a Unix socket, so it's not really, you can't really connect to it in the same manner. So yeah, like this is primarily like an attack against Windows. It's a bit easier on Firefox, though because of the Quad 100 attack and the attack they detail in the later half of the blog post, it does work on Chrome as well with that one. But yeah, it's quite an interesting chain involving, multiple rebinds for the Chrome root at least. And yeah, like the main issue is just that they're able to get access to that API and they're able to do some weird stuff. I found the information disclosure particularly interesting, where it's like the GET request they would censor out the node key, but then in the patch request they didn't. I guess just like a lack of centralization or something. But yeah,
That's somewhat hard
some
to
cool vulnerabilities.
centralize. In
Yeah, I guess
fairness,
that's
like
true.
they're different requests, it's printing different things. I can definitely see how that happened, but yeah, I mean, interesting nonetheless. I'm just trying to think, like, patching it would just be applying it in both places, I suppose. Um, I don't know if there's ever really a good. I'd be interested if there is actually a reason why they need to disclose it at all after the patch request.
Hmm.
Something else you could do is, you do the patch and then a get to see the updated values, and so they hiding that way. And by trying to echo it in the patch, maybe try to do too much.
Yeah. Something else I found kind of interesting too is related to the tail drop stuff you were talking about for how they took advantage of some of the issues. They mentioned that like tail drop is a convenient feature, but it's disabled by default. But it can be enabled by the like tailnet administrator, and where Z mentioned you could take control of the control plane. Um, you know, as an attacker, you can just basically re-enable it on the user's behalf. I thought that was a little interesting. It seems like a bit of like a weak design that like a malicious administrator can just re-enable tail drop without you consenting to it. Um,
Well, I mean, that is kind of more of a network feature, though, too.
yeah.
So it kind of makes sense that would just be something on this network we allow or disallow. And the fact that an admin can do that for their network makes sense. Like, that is something I wouldn't necessarily want all the users being able to just, oh, I want to turn this on because I feel like it.
Well, what I was thinking was like it should be enabled on the server and then you opt into it on like a user basis, but yeah, there were just multiple things in this blog post where I felt like there wasn't a lot of defense in depth, where it was kind of one of those things where as soon as you got access to that local API, it was like kind of like open season. There just wasn't really much preventing you from doing what you wanted to. Um, but yeah, I mean, I guess that's not too much of a surprise considering we've seen other like kind of software like this where it's the same situation. But yeah, there were a few things in this blog post where I was like, yeah, if this was designed like a little bit better, it would have like killed this chain a bit earlier on. But that's just not how it worked out. So
Yeah, I mean, it's they kind of shout out just H actually I guess it's somewhat related, but having like HTTPS style access proxies kind of in front of any sensitive thing. I guess that wouldn't necessarily prevent the rebinding aspect, but um no, I guess it would actually. If it was expecting at least a valid TLS certificate, it would need to validate that so the domains wouldn't match. Um and you'd get the issue up there, which is just a good practice. Even having some sort of CA that's just for Tailscale could make sense there. Um, and that just, if you stop it at the rebinding aspect, the rest doesn't even matter. On that aspect, though, they do mention that tail drop isn't enabled by default. And I believe if it's not enabled, you can't really go for the full chain of rebinding on quad 100, getting to the peer API, then accessing peer API. Because your peer API, where you get that XSS from, that's depending, I believe, on this tail drop feature, which would be
I actually
disabled.
think it's the other way around. I think the tail drop relies on pure API, and pure API is exposed and like like enabled by default, even if tail drop isn't enabled. That's the way I read it. Maybe
Okay,
that's wrong.
well, so I guess it was something I was a little bit confused about reading it because they talk about pure API early on, or sorry, they talk about tail drop early on as how they're doing this file sharing. Um, and then yeah, they do mention here that like the pure API port is what how you send them with tail drop. But I guess it's not clear that the pure API, like if you access it directly, wouldn't have it. My assumption would be if you disable tail drop, then the API endpoints of tail drop would be disabled. That's my thinking. But yeah, they're not explicit here, and I don't actually know that. Um, so you could interpret this, I guess, either way. They don't call it out, so perhaps it is more likely to be your interpretation here.
Yeah. I feel like that's the only way it really makes sense that the attack can work, but
Well,
maybe I'm wrong there.
otherwise, it just depends on having that enabled, which, while not
Yeah.
a default feature, very well could be a feature that does get enabled.
Yeah. But yeah, overall, like a cool set of issues. There's a lot of issues in here. It is a fairly dense post. Um, but it's an interesting chain and how it works and taking advantage of different features like tail drop. Yeah, that's some cool aspects to it for sure.
And one thing I will also mention is they offered a $10,000 bounty on this one, despite them indicating that they do not have a bounty program. So nice to see a bounty come out of it. Not so nice to see that a somewhat security focused project doesn't have a bounty program.
Oh, I totally missed that. Good catch. Yeah, it's pretty cool in this specific case, anyway. Yeah.
And they
All
got
right.
some swag too, I guess. I'll mention that Tailscale merch and voucher for pro account. So that's something. I
Yeah.
mean, the bounty makes sense. It's more just like would be nice if they had an actual bounty program, especially
Or at
given
least a
their
VRP.
position. Well,
Yeah.
they do have a VRP. So they do have
Oh,
they have the
okay, they do.
security page. They just don't have a bounty program. But yeah, no, they did have a way to actually do the contact here and stuff. So at least they're
Fair
doing
enough.
that.
Okay. All right. So up next we have an SQL injection in the Password Manager Pro component of ManageEngine's PAM360. That's Privileged Access Management and Access Manager Plus. So this was posted by ZDI. And it's a vuln that can be exploited through resource types in this auto logon helper util class. So in the password manager, there's this concept of resources which can be added or edited. Internally, it uses a multi-part form request and submits it to the add resource type endpoint. And this auto logon helper util class will be used by several other controllers to basically construct partial SQL statements for the existing resource type. The problem is it seems to just use that resource type name without sanitizing it at all against SQL injection. So by adding or editing a resource with a malicious resource type name, then clicking on something that triggers that resource name to be used, like the connections menu, you can get SQL code execution. So yeah, this one's a fairly trivial bug, but it's a little bit interesting where it happens and the control flow for it. Um, it's not exactly an obvious place to expect there to be like a SQL injection, I guess. Um, Especially where like you need that extra step to trigger it. Though this is one of those attacks where you would already have to have some access to the control panel as an attacker. You would need to be authenticated, which for something like a password manager is a pretty damn big ask, I feel like. So I think the impact here is pretty limited. Nonetheless, they provide some detection guidance on inspecting requests and whatnot, but yeah, this probably isn't something that's going to be super useful for an attacker. But yeah, I mean, it's a little bit surprising to see like such a straightforward and easy SQL injection in something like ManageEngine because I think we've covered it a fair bit before on the podcast.
Manage
Um,
Engine is something I'll see the title when prepping for the podcast, getting things together. I'll see Manage Engine. 90% of the time I'll skip over because they don't have a great track record.
yeah,
At least not in my experience. yeah, let's just say there have been a lot of vulnerabilities we just haven't covered. That said, I thought this one would be a little bit more fun to cover simply because it is just well, as you said, there's a little bit of that extra step, second order aspect kind of for the SQL injection. Other than that, it's a straightforward SQL injection. And we just don't bring that up too often because it's not that interesting. And as a vulnerability, it really isn't that interesting. But it's still there. It's still present in major software. So
Yeah.
kind of just bringing it up more for that sake.
Yeah, that's kind of what I was getting at was like, you wouldn't expect to see this in like major like industry software, but yeah, it's still there. So this is a good reminder of that. But yeah, pretty quick one. Not too much to that blog post. Fairly straightforward issue. They go through a good bit of the detail of like the control flow and how it's reached and the exact requests and whatnot. But yeah, you can mostly skip over that. It's a pretty straightforward issue.
Yeah, and I'll also mention like fun thing with this is it's also got stacking enabled. So like you're running your SQL query and you're not bound to just the one type of query. Like if you have an injection and a select, you are oftentimes you're bound to just selecting things or like messing with that query. With stacking, semicolon, brand new query, you can do everything. As they mentioned, I guess you didn't mention it, but kind of the lack of defense and depth too, that's running with system privileges from SQL Server, probably get code or can potentially get code execution too.
As system. Because I think they
Exactly.
mentioned that it runs a system.
Yeah, it does. So they mentioned it's running a system. I assume you can go for full code execution there, not just SQL injection, although that will depend a little bit on settings. But again, just defense in depth, having, a less privileged user for doing queries and all of that. Um, yeah, I mean it's a silly issue to see, but we don't cover enough of those. Well, actually, I don't think we want to cover too many of them, but it's nice to see.
Yeah, it can make for a cool exploit and a nice and easy one. All right, so our next post is by Oxeye, and it's about an unauthenticated RCE in Spotify's Backstage through a VM2 sandbox escape. So it's leveraging a previously known vulner exploit that Oxeye detailed a month ago to hit Backstage, which is like a backend manager for managing infrastructure and microservices and whatnot.
Yeah, it's more of like creating a dashboard for developers. So a dashboard of all like the internal services. You've got like a catalog system in there, templating, which I'm sure you'll get into, but a lot of features that are meant to make it nice for the developers building their own dashboard.
Yeah. And it's used by pretty prominent players in the industry as well. Like it's used by Netflix, American Airlines, Epic Games, and of course Spotify, where they're incubating it, as well as a few others. So yeah, it's a fairly like well used piece of tech that's used in the industry. And as Z mentioned earlier, like notably Backstage also includes software templates that are YAML based that can quickly be used for spinning up new projects or plugins or whatever. And one of the things that these templates contain is a message parameter, which is rendered by Nunjux, which is like a JavaScript templating engine. In previous research by Oxeye, they noted that this could be used to run shell commands, and it was a fairly dangerous functionality, through like Node.js or whatever. So Backstage used the VM2 JS sandbox library to try to mitigate it as an attack vector. Unfortunately, they don't really talk about what VM2 does. I'm not too familiar with it. From what I understand, it tries to prevent you from accessing like global objects, so that you can't just invoke some powerful object like API to get easy command injection or something.
Yeah, like I'm
Um,
not familiar with the internals there, but effectively, I mean, it creates a sandbox environment for that JavaScript to run. Not quite as strong as like either a container or a VM, but strong enough to like maybe run some semi-trusted stuff. And just on that note, I will mention nunjux and like the template injection. Basically, kind of talking about the same realm with server-side template injections. So yeah, getting RC isn't that unexpected if you're able to get control inside of a template. It's generally expected to work on trusted templates, not untrusted. Like you put untrusted values into the template, but the template itself is usually trusted. So it's not a terribly unexpected thing to have that escape. They don't really talk about what or like how they get code execution there. They're just like, you could do it. I kind of want to clarify that it's pretty well expected that you could do it with that level of access.
Yeah. So Oxeye recently discovered a VM2 sandbox escape and wanted to see if it would work here. Spoiler, it did. And yeah, that sandbox escape is detailed more in a blog post from a month ago called Sandbreak. I'll bring it up here. Um, so yeah, the basic idea is, like I mentioned, the sandbox will try to prevent you from getting access to like the global objects and critical functionality to execute system commands. And the basis for their sandbox escape is the fact that Node.js allows you to customize the call stack for things like errors. So you can override the prepare stack trace method under the global error object to get your callback ran when an error is thrown. And in the arguments to that, it'll provide the error as a string as well as an array of call site objects for the stack frames. Um, what's troublesome is those stack frames can contain objects that are outside of the sandbox when the get this method on them is invoked. So the VM2 maintainers knew of that, and they tried to prevent it by wrapping the error object with their own implementation, which would prevent overriding of that prepare stack trace method. The thing is, it seems an attacker can just override the global error object itself with their own object, which can then again override prepare stack trace. So it seems like an attacker can basically just supersede VM2's error object and again gain the ability to escape the sandbox through the stack trace
Yeah, and
functionality.
honestly, I love that. Like, just as an
It's
attack,
funny.
it's just like, oh, you won't let me override error.prepare stack trace? Okay, well, let me override error. Like,
Yeah.
it's just going around it, just like such a fun attack. Such a great way of doing it. Straightforward, easy to understand too, which is always nice. But yeah, I really like this. Unfortunately, I didn't see this post back when it first came out. Shame on Oxeye for removing their RSS feed. But that's besides the point.
Yeah. But that situation with the sandbox escape is like a classic cat and mouse example. So yeah, it was fun. Um, but yeah, so they wanted to see if they could apply it here. Now initially when they tried it, they ran into some problems. Because Backstage would use strict mode functions, and it seems that functions that are in strict mode can't access the receiver. So they had to do a bit of work to try to figure out a way around that. What they ended up doing was iterating through the stack and the stack trace and finding the earliest function executed in strict mode, which was this render string 2 function. They don't really go into detail on what that is, but it isn't particularly relevant beyond the fact that they can basically override that render string 2 method and try to force it to run in non-strict mode. On top of that, they discovered that when an error was raised when rendering the template, render string 2 would get called again. So what they can do is they can override render string 2, trigger an error, and then get their overridden function invoked. So kind of similar to the sandbox escape, basically. They're overriding the method, forcing it to non-strict mode, and then chaining their attack on top of that. So
Yeah, and
yeah,
I
chaining it all
guess
together. Go
I
ahead.
will just mention strict mode if you're unfamiliar with it, as I was. You can kind of do it or implement at like a function level, but if you've seen that string use script, it's that. Usually, at least for my own experience, I've seen that like the top of a file, but it can also be introduced at a function level. So by overwriting the first function that introduces it to be not strict, you're able to get around having strict on there. Sorry, go ahead.
Yeah, so chaining it all together, they override render string in non-strict mode, trigger an error, get their code invoked in the context of the sandbox. Then they back up the error object, override error, implement their own prepare stack trace, and get a call site object to run system commands. Now you would need the ability to mess with the templates in Backstage to take advantage of this, which initially made me think the impact of this wouldn't be too high. It seemed like it would be a big ask, kind of like what Z said. You're expecting more trusted data to end up being parsed as templates. But interestingly, it seems that Backstage is deployed by default with no authentication mechanisms, which is just like
Oh
made
no,
me
it's worse than
question their
that.
systems.
I mean, yes,
Well,
by
it does get worse
default,
than that. I haven't gotten there yet.
true, but like by default, I kind of get that. There's a lot of things, especially backend things. Actually, I'll let you explain the next twist before I go into that.
Yeah, so there were some Backstage servers that were public on WAN that didn't need any auth. Beyond that, though, even when there is a sign-in page, Backstage has a warning that notes that the sign-in page and identity management is not considered an authentication barrier. It's basically just for personalization. You can still access the backend API and everything. So, yeah, like even the sign-in that is there that you think might keep you safe doesn't really do anything on that front.
At least they warn you, but yeah, like, I kinda get the sentiment where, oh, not having authentication on these backend things because, that'll probably get implemented at, like, a reverse proxy layer that implements auth in front of these applications, passes it along. So, the default of it being, implemented without auth doesn't entirely surprise me because of that fact, like, the place where this getting deployed. But this whole thing where it's like you could sign in for a purely personalization aspect and, like, not having an option to turn on, like, a required login, like, it feels like a feature that's just lacking the most obvious part of it. Um,
It's very misdirected, like, yeah, it's very easy to get tricked by it, I feel like.
at least they
Tricking you into,
warn.
like, a false sense of security. I mean, yeah, but who reads like, do you think everyone's reading the documentation page that has this warning?
I mean,
Um,
it's better than nothing, but yeah, like, it's one of those things where I get the starting place, not having auth, but if they're going to implement a sign-in, they should go that one step further and have it be able to be enforced. It's like it
yeah.
wouldn't take that much extra code to just enforce that sign-in. Like, it should just be able to do that. The fact that it doesn't, oh no, there's maybe something about how it's used that leads to this, but if this really surprised me, it really stands out to me as a very weird implementation choice. Even if they're not using it, when you go through that hassle of implementing this functionality, take it that little bit forward so you kind of don't violate that whole law of non-surprise or whatever it's called.
That's what I
Just,
was thinking of. I was trying to think of the name that we talked about before, the law of non-surprise. Thank you.
I'm not
Um,
sure if that's the proper name for it, but like that concept at least.
It's better than I had, which was nothing, question mark, trying to remember what it was. But yeah, like it violates that principle of least surprise, and it also is just like an insecure default sort of situation. I can kind of understand what you're talking about, where it's like, ideally attackers shouldn't even be able to reach this functionality. It should be proxied off or whatever. But yeah, I mean, again, coming back to like the insecure defense or like no defense in depth, really. Like, yeah, basically, if Backstage is accessible, an attacker can exploit this vulnerability for the most part. So yeah, they ran searches on Shodan and found a bunch of instances where they could exploit this without authentication, basically. So yeah, I mean, it's a pretty impactful attack. It's way more impactful than I initially thought it would be, given the premise of their attack, which is, attacking the templating engine. So, yeah, it's a bit of a weird scenario. And like I said, Backstage is, it's incubated by Spotify. It's a big company. It's used by other big companies. Now, hopefully and most probably in those other big company scenarios, it's not going to be exposed on, WAN. You're not just going to be able to connect to it and do this. But on a lot of smaller companies or like hobby projects or whatever, it's it's hard to configure servers properly to do like reverse proxying and isolate things like this off. So yeah, it's probably a fairly common among projects that use Backstage. It's probably fairly common that this could be exploitable. So yeah,
I don't
pretty
know if
impactful
I'd say
overall.
that actually. I don't know if I'd quite agree. Yeah, there is some
You'd want to
complexity.
backwalk it a bit.
I'd say there's some complexity to putting things up behind like a reverse proxy or something, but usually where I imagine this being used is more the larger enterprise that have like a ton of microservices and such to actually manage with something like this. And they're also the type that would have already spent some time implementing that sort of system if they like their auth system for these things. Like it feels to me like this would come in later into their whole development process and thus less likely to be exposed. They found like 500 cases, so I mean, mixed bag, I guess. Um, it just feels to me like the sort of thing that by the time you're exposing this, by the time you're running this, you probably already have some sort of like prod environment set up and things like that to work with. Maybe I'm just overly optimistic on that, but I guess the question comes down. They had 500 instances. How many of those instances were like things that mattered versus just like trying it out? And how
Yeah,
many more instances are actually run?
yeah. Unfortunately, we just don't have that data, so we kind of have to guess. But yeah, I mean, impact aside, it's a pretty cool attack, and I really like the VM escape and how it works.
Yeah, so did
Um,
I.
yeah, but it kind of implies that like yeah, VM2 sandboxing is there. It reminds me almost of like Python sandboxing, where it's like it's there, you can use it, but it's not particularly strong. That's kind of my takeaway from the VM2 sandboxing stuff. But
All
yeah,
those Python sandbox VM escapes, CTF challenges. Used to
yeah,
be a really common category for a while.
yeah. So yeah, both these posts are here. You do kind of have to go off to their other posts to understand more about that sandbox escape, but yeah, it is linked there, so it's pretty easy to get to. All right, so we'll get into our last post here, which is by Hex ACB, and is about a tool called REcollapse, which was published last week, which is basically like a black box regex fuzzer for fuzzing normalization-based issues in web apps. Z, you found this one, and I'll let you talk about it a bit here.
Yeah, I thought this one was interesting. It is just the one. It's a application of fuzzing onto the web. I always like seeing that, but kind of as usual with this, like you've got different ways of fuzzing. You don't have good ways of actually detecting an issue happened or not. Whether or not something's actually vulnerable. I think they recommend in here basically just your last step is actually looking and seeing if it did something weird or like, yeah, analyze the results, sort by response code, response length. Not really much really tell. Besides some heuristics on what you should look at. Nonetheless, it does talk about effectively fuzzing different validation routines. Specifically, they're kind of targeting those that do regex validations because there are some interesting problems. And I like this post. They bring up one of my favorite regex issues that can pop up, and that is the use of the caret and dollar sign. Um, if you end up thinking about caret and dollar sign as start and end of a string, actually be mistaken if you're in multi-line mode, which either can be enabled or might be on by default depending on your language. If you end up in multi-line mode, caret and dollar sign match the start and end of lines, not the start and end of a string. And so you can have something. There's the Ruby case here, where you have the regex matching just A to Z plus, so any sort of printable character. Um, that's all it's supposed to match. But if you give it the AAA new line 123 using that caret and dollar sign, it's going to match an entire line in that the three A's and new line. It'll match that, and it'll see that's a new line. It'll say this string is okay if you're just testing it to see if it matches like as like that sort of validation. It's okay. So that's one of my favorite regex issues to see because it's subtle. You have to understand the difference between caret dollar sign versus a backslash a and backslash z will give you the actual like start and end of the whole string, or you can do a different mode which treats caret dollar sign as that. So there's some complexity there. It's a fun issue. It's easy to make. It doesn't always pop up anywhere super sensitive though, but it is something you can kind of test for and fuzz for with some of these cases. So what they're trying to introduce here, what they talk about a lot, is just getting into some of the issues that happen with regex, and then trying to fuzz the right areas. Those these as they're calling them like the transition points, normalization points, and separate, or I guess separator, not transition, but um noting those points and then fuzzing those areas specifically. The other thing is normalization, like dropping something down to lowercase. They have this wonderful URL example here, Shakespeare. Uh, yeah, well, without vowels, but Shakespeare.mobi. You can see it printed on screen. If you can't see it, it's just got a bunch of like emoji type characters, UTF things in there. not your normal characters, but if you were to actually put that in your browser, it would just take you to lowercase version that gets normalized down to just more standard characters. So you can kind of play around with that. A bunch of ideas here, just another fuzzing tool to take a look at. Toss it out whatever endpoints you've got. I
Yeah, good to
it's
be aware
gonna
of.
Yeah, I mean it's going to turn up bugs. Regex is hard. These things happen like all the time, and there's just a bunch of foot guns with regex and ways to do it incorrectly. It makes sense to go for fuzzing here, and they're just trying to do in a more smart way. So yeah, I figured I'd shout it out there. They released a tool with this also. And yeah, I mean, on a whole, just a good post, not just for the tool, but just talking about the issues if you're unfamiliar with them. So figured it would at least be a shout out here.
Yeah, regex is like the C++ of the web in a way. It's like it can do some powerful things, and because of that, it's used a lot. But it's also like it can be really stupid, and it's really easy to misuse. Yeah. So yeah, with that said, that's basically all the topics that we have for today. So
Before we
thank you.
end,
Oh, you have something to add? Okay, go ahead.
yeah, I was just going to say, Miss Siki out of chat asked a question that fortunately isn't super well targeted for a bug bounty podcast, but I figure we might have some to say there. And what's better than IDA freeware? Which would be a little bit more relevant on tomorrow's episode, being our more binary focusing. But I mean, IDA freeware is honestly pretty good for what it offers there. That said, Ghidra. Ghidra is free. Ghidra can compete with IDA Pro, not just IDA Free. Binja Cloud's there. It's got some limitations on like file size and stuff. If you
I think
listen
it's
to
too limited to be very useful for
yeah,
most
like
use cases.
I think the big thing is really the size limitation on Binja Cloud.
Yeah.
It just means like a lot of real world applications you just can't use it there because it's more than 5 megs. Um, but yeah, Ghidra I feel like would be the best competitor there. Um, yeah. If you want to pay Binja Student, like if you can get the student discount, I think it's reasonable. It's not. It is still paying, but it's not super expensive. Um, but
Yeah,
yeah,
I think
I'd say Ghidra.
people overlook like IDA free and how useful it can be. For x86 and like PE and L files, it's basically unparalleled. It's really good.
Yeah,
You are on the cloud decompiler, like because that's the thing. IDA freeware even has decompiler now. You are using cloud, but presumably if you're using IDA freeware, you're probably not working on binaries that are super sensitive anyway. Um, you're probably doing like hobbyist stuff. So yeah, IDA freeware is really good where you can use it, and where you can't, yeah, I would say just use Ghidra unless you want to, pay for Binge or whatever, and give that a try.
yeah. I
But
mean,
yeah,
personal recommendation. I don't like recommending people go into the IDA ecosystem early on. Now that you have Ghidra and stuff, I'd say start with that over IDA freeware. Just don't go into the IDA ecosystem. But if you've listened to the podcast for any period of time, I'm kind of anti IDA.
and anti hex rays day zero.
Yep. I mean,
All right.
in fairness, like IDA is the best on the market. I'll give them that. I'm not saying it's bad. Just if you're starting, Ghidra is not $10,000 worse than IDA. Um,
Yeah. All right. So yeah, we'll wrap up our episode there. So again, thanks everyone who tuned in. VOD will be up on Twitch immediately or on other platforms like YouTube tomorrow. If you want to join our Discord and follow us on Twitter, links for those are down below or in the chat. But yeah, we'll be back tomorrow with a binary episode. That's at 7 p.m. Eastern, 4 p.m. Pacific, where we'll talk about more of those binary focused issues. And yeah, we'll see you then.